Again, let's talk about eccentricity, but this time for hyperbolas. Again, eccentricity equals c over a. But again, if we're talking about hyperbolas, the formula to find c is different. For hyperbolas, it's c squared equals a squared plus b squared. So the formula for eccentricity is the same. It's just the formula that's for c, or c squared, that's going to vary between the hyperbolas and the ellipses. So here's an example. Find the eccentricity of the following hyperbola. So for this first hyperbola, we have the equation x squared over 2 minus y squared over 18 equals 1. There's our equation. So to find the eccentricity, we need c and we need a. We have a and b. Remember, a always comes from the major axis. Remember, with hyperbolas, it always comes first. It's not based on size. So your a squared is actually 2. So then a is found by taking the square root of both sides of that. Well, if you do that, that tells you that actually a equals the square root of 2. Doing the same thing for b, if you're looking at the other denominator, b squared is the 18. So to find b, you would again take the square root of both sides of that, which means b is the square root of 18, but that can be reduced because 18 can be broken down into 9 times 2, and the square root of 9 is 3. Unfortunately, the 2 you're stuck with, it's got to stay inside of the square root. So that means that b equals 3 square roots of 2. Okay, so we've got a and b. We still need to find c to find eccentricity. Remember, for hyperbola, the formula for c, or c squared, is a squared plus b squared equals your c squared. Well, we just said that a equals the square root of 2, but according to the formula, a is squared. So if you square a square root, remember they'll just cancel out, leaving you with the 2 underneath. Well, we also had, if we want to look at the simplest version of b, that b was the square root of 18. So if you plug that in, that b is the square root of 18. And again, same idea. Notice that again, b is squared. So squaring a square root will cancel each other out and leave you with just the 18 underneath. So what does this give you? It tells you that c squared is equal to 2 plus 18, which is 20. But again, be careful, that's c squared, not c. If you want to find c, you still have to take the square root of both sides here, which gives you that c is equal to the square root of 20. Be careful, that's not done, because you can break down 20 into 4 times 5. You can, luckily, take the square root of 4. The square root of 4 is 2. You cannot take the square root of 5, so you're stuck with that. That has to stay inside of the root. But at least now you have a, b, and c. You needed the c to find the eccentricity, no matter what. The formula for eccentricity for a hyperbola or an ellipse is e equals c over a. Well, we just found c was, what did we find c was? We found c was 2 square roots of 5, so we can plug that in. That we can replace c with 2 square roots of 5. We also already know that a, from above, way back when, at the beginning of this problem, was square root of 2. The problem that we've had throughout all of our math courses is you can't leave a square root on the denominator. So to get rid of the square root of 2 on the denominator, you have to multiply the bottom and the top by a square root of 2. What does that do? Well, on the bottom, when you multiply the square root of 2 times the square root of 2, it will just leave you with a 2. And be careful on top. What happens is you have a square root of 2 times the square root of 5, which is the square root of 10. Don't lose the 2 that was out in front either, though. There was that 2. So what that does is that gives you 2 square roots of 10 over 2. But then what you can notice happens is those 2's on the front and on the bottom cancel out, leaving you with just the square root of 10 that was up on top. So you just get the answer, square root of 10, and that's your answer for the eccentricity.